solving a trigonometric equations, and it's really important that we understand the difference between approximate value and exact value. I'm hoping through these more rigorous examples, we sort of get a flavor for what they mean. Also, you'll see the equations that we're trying to solve getting increasing in complexity. So in our first example, we're going to be solving for theta, where theta is between 0 and 360. And we are going to be solving tan squared theta minus 3 tan theta plus 2 is equal to 0. So we've previously done some exercises where we're factoring the trigonometric ratios. So whenever we see an equation of this complexity, really what we're going to do is we're going to factor to isolate each trigonometric ratio. And then once we have each ratio, in this instance tan, isolated, we are going to be solving for the angle. So, or angles. Just so you know, this has 4 solutions. So let us get started. I'm going to be factoring this. So when I see tan squared theta minus 3 tan theta plus 2, I'm going to be choosing to factor it. So if you wish, please press pause and factor. Okay, hopefully you press pause. I am going to be factoring this. Make sure that my tan thetas or my tans have a theta beside it. So now what two numbers multiply to positive 2 but add to negative 3? That would be negative 2 and, negative 2 and negative 1. So I factored this. I've made sure this was equal to 0. Now I'm going to use the zero product property. So if two things multiply together to be equal to 0, we get our first factor can be equal to 0, or our second factor can also be equal to 0. Now I have two factors equal to 0. Tan theta minus 2 is equal to 0. I'm going to isolate for tan theta, so we get tan theta is equal to 2. And from the second factor, we should get tan theta is equal to 1. Hopefully that was all right. So now this, here on end, really we have two smaller equations. So I'm just going to put an invisible line right there, or maybe not so invisible. And I'm going to solve this like regular simple trigonometric equations. Let us start off with the left-hand side. I'm going to draw my unit circle because that's what I do. Where is tan 2? Tan is 2 in quadrant 1 and quadrant 3. Now, is this an exact value or an approximate value? Well, this will be an approximate value. How do I know? Well, I'm going to look at my unit circle. Envision that I'm taking my unit circle out. Maybe you have it in front of you. If you don't, you may want to press pause, take it out. Ask yourself, where on the unit circle, or in other words, which special angle has a tangent of 2? There is none. So what we have to do then is we have to approximate the angle. So here's my output from the calculator that I used. So I'm going to be solving for theta. Theta is going to be the inverse tan of 2. And the output from this gave me 63.435 degrees. So maybe I'm going to give myself some more space on the paper here. It's never fun when we run out of space. So from this, I can get my theta 1 solution. So this solution up here is going to be 63.435 degrees. Now, the reason why I like drawing a circle so much is because often we forget that as soon as we touch a calculator, a lot of our reasoning goes out. So I'm going to calculate this quadrant 3 angle. I'm going to call that quadrant 3. If I know my quadrant 1 related angle is 63.435 degrees, theta 3 is just going to be adding 180 to that amount. So that is 243.435 degrees. So I'm just going to put a box around it so that I don't forget. These are approximate values. Because they're approximately, right? I had to approximate them using a calculator. Now I'm going to solve the right-hand side. Don't forget about this one. I'm going to ask myself, where is tangent equal to 1? So I'm going to take my unit circle. I'm going to draw it right there. And if you notice, I do know where tangent is equal to 1. If you look at the unit circle, your tangent's equal to 1. Where? Exactly when theta is equal to 45 degrees. Now, this is an exact value or memorized value. It is a value that is obtained using those special triangles. Therefore, it's called an exact value. So there is another theta 1. We have another theta 3 angle actually that can solve this equation. So theta 3 is going to be 180 plus 45 degrees. So I have my 4 solutions here. When I write out a solution, generally speaking, therefore, theta is equal to, have to include it, generally we write it in ascending order, 45, 63.435 degrees, 225 degrees, and 243.435 degrees. So those are my solutions.